next question. The fixed points A, B, and C. By the way, if you think I've made a mistake anywhere, please feel free to comment. I need to rectify that. I'll just do it in the comment section. Okay? So make sure you point out my mistakes. I doubt I'll have any. Hopefully I don't have any, because I'm here teaching M1. If I make any mistakes, bro, that's just gonna look bad on me. Okay. The fixed points A, B, and C lie in a straight line on a horizontal road. At time t is equal to 0, motorbike passes through A with speed 5 meters per second. Okay. Oh, these questions, bro. Labor-intensive questions. I hate these questions. The fixed points, although not as much as vector questions, or some lengthy vector. Oh, God. Those vector problems, they suck. All right. Oh, but don't be afraid of vectors, though. Okay, they're actually really easy once you get the heck of it. All right. At time t is equal to 0, a motorbike passes through A with speed 5 meters per second. So A is just a fixed point on a horizontal road in a straight line. Okay. So you have the line here. Let's say this is A, and the car. Is that a car? No, it's a motorbike. It passes this point with a speed of 5 meters per second. Now from A, the motorbike accelerates uniformly until it reaches B with the speed of V meters per second. So it accelerates up to V meters per second, okay, and then reaches point B. Okay, we don't actually know how long this B is. Okay, actually, you can see this here. The distance AB is 132 and the distance BC is 136. So it's actually, okay, greater. So let's just say like AB is like this much, and then BC is going to be that much. And what I like to do is write down the distances as well. So this is 132 and this is going to be 136. Okay. Now, what do we do? Okay, it says it reaches to a speed of V. Okay, so we write down V meters per second here. I know that it accelerates uniformly. Okay, of course uniformly. You wouldn't expect non-uniform acceleration. You wouldn't expect variable acceleration in M1. Okay, the motorbike takes, also just one thing to note, the Subat equations that you use in M1, they're only for constant acceleration. You can't use them if your acceleration is changing, if your acceleration is a variable, right? A variable as in it varies, you know. Okay. The motorbike takes t1 seconds to travel from A to B, so this takes t1 seconds, and the motorbike decelerates uniformly until it comes to rest. So it's actually at rest when it comes to C. So it actually decelerates. Now I can't just name this A. I can't label this A, right? Because, well, they're on the same, of course. So what we can do is we can call this A1 and call this A2. And this takes t2 seconds, as it says here. Now we have to sketch a speed time graph of the motion of the motorbike as it moves from A to C. We have to sketch a speed time graph. So now that we drew this little thing here, I mean, of course, you can straight out read the question. Read this first. It says you have to sketch a speed time graph. So what you're going to do is just read this, all these lines essentially by one, and then just draw the graph as you read through that. But this also does help a little bit. I don't know, but I mean, whatever you're comfortable with, you know. I just like to do this. Then we're just gonna draw the graph. Okay, speed time graph. Let's do that. And there we go. Make sure to label and put down the units as well. And here we're gonna have time, seconds. All right, now sketch a speed time graph for the motion of the motorbike as it moves from A to C. Okay, so we know that at A, so like at the initial time at t is equal to 0, this is the time axis, here's time 0, and at that point the speed is already 5. We're not starting from rest, we're starting at 5 meters per second. So essentially, I mean, you could argue that how can a car like not start from rest? How does it already have a speed to begin with? Well, first, that's just very simple. Well, you start the car, and as you reach 5 meters per second, only then do you start the stopwatch, right? That's what's going on here. So if you're just confused about that, there's that. Okay, so we start at 5. Let's say 5 is like there, I guess. Doesn't really matter. They just asked us to sketch. This is no, it doesn't have to be that accurate. Next up, okay, we don't even have to look at the question now. We have this little diagram that we drew. Here we accelerate until we reach V meters per second. V is like let's say here. What do we do next? Then we decelerate. Okay, let's just double check if we have missed anything. Takes T1 A to B and then decelerates. Okay, we haven't missed anything. This is okay, then we just decelerate to 0. Okay, that's just it. Now what about the time? Well, from 5 to V, it takes us T1 seconds from A to B essentially. So this is A and this is where we reach B. So all of this distance traveled right here is the distance traveled to go from A to B. That is 132 meters. And we know that the area under the speed time graph is distance. Very simple. If you still don't know this, man, what have you done? Come on, go and revisit, just revise the topics and come back to this video. Okay, we have T1 here and then here we have, okay, now we can't just write down T2 here. That wouldn't make sense because what is T2? Ask yourself. Well, T2 is the time taken to move from B to C. So the time taken is from B to C. So this would be T2, this length right here. The length of time would be T2, but when you write this down on the axis right here, you're gonna have to include T1 as well, right? Because we're essentially counting from the origin. So from the origin, we've already reached T1 and then we're going to another T2. So essentially this point is T1 plus T2, okay? Don't mess this up. That can cost you some marks. And you're gonna miss out on full EMS. Okay, now let's just why don't okay, in the exam just refrain from shading just like that. Okay, it just doesn't look good. What you can do though is write down the distances here, 132 meters and this would be 136 meters. Very simple. And this is point C. You could just write these down. And don't think that if you just write these extra points down, you're gonna be suffering a loss of marks, right? Because, well, you're not doing anything wrong. These are all facts of this question, okay? So don't worry. Now, we need to find out, in terms of V, an expression for T1. We can do that. We can do that. If we just consider the first part right here, the first trapezium, if you will, we can say that 132, as I've already mentioned, that the distance under, the area underneath a speed time graph is equal to distance. So the distance is going to be equal to the area, and the area of this shape is a trapezium, is going to be base plus the top side. So like the two parallel sides, you're going to add the lengths of those up. So the length of this is going to be V. So you have V plus the length of this is going to be 5 divided by 2 times the height. Height, essentially, it's best if you don't call it height all the time, because now you can see that this trapezium is, well, rotated. So now calling this the height, that wouldn't look nice, you know. So what you say instead is the distance between the two parallel sides. That is what we need, and that is simply T1. So there we go, we just have an expression, and we don't have to, I don't think we have to like simplify this further. This is just fine. And for 2, we're gonna have, well, what do we do for this? Same thing again. We know that the distance is 136, so this is going to be equal to the area, basically. 136 is going to be equal to, what do we have? This is a triangle, so we need half times the base, which is this length right here. That's going to be T2, not T1 plus T2, okay? This is just T2 multiplied by the height. The height is just V. Okay, in terms of V, they said we have to express T1. Okay, guys, my mistake. They said find in terms of V an expression for T1. So it's best if you just make T1 the subject here, okay? Just to be sure, okay? I don't think they're gonna cut the marks, but you never know. They're pretty salty. So you have 264 here divided by V plus 5, and that's it. And for T2, it's going to be 2 times 136 this time. That is 272 divided by V. So we have our T1 and T2. Now, given that the motorbike takes 28 seconds to travel from A to C. Okay, so in total, it takes 28 seconds. So we can say that T1 plus T2 is 28. This is part D, right? No, this is part C. Okay. Now, they're asking us to find the value of V. Well, how do we do that? How do we do that? Okay, I think we just... Wait. We have to solve it simultaneously or something? Wait, no, that's not gonna work. Wait, I think I know what's gonna work. That is, we can actually just consider this whole thing, right? Like the entire graph, the area underneath the entire graph is 132 plus 136, the entire distance from A to C, that is 268 meters. So you have the distance, which is 268 meters. I'm writing this down right here. This distance is traveled, and I know that this is going to be equal to the area. What is the area of the whole thing? Well, the area of the whole thing, we could say, is just, well, okay, no. We don't have to go down that road. Yeah, I'm really sorry. I didn't see this earlier. So you have this T1 and you have this T2, and adding these two up will give you 28. And then the only variable you'll have in the equation is V, and then you can solve for V. So let's just do that. 264 by V plus 5 plus 272 by V is equal to 28. Okay, now what we can do is take the common denominator, or take LCM, not common denominator. Take LCM, and then we're going to have 264V plus 272V plus 272 times 5. 1360. That is equal to 28. Alright, now, okay, let's just bring this down here. 264 plus 272, 264 plus 272, that's going to give us 536V plus 1360 is equal to 28V squared. We're going to take this denominator onto the right side. Essentially what we're doing is multiplying both sides by V times V plus 5. So this cancels out on the left hand side, and on the right hand side we're left with just that. So you have 28V squared plus 28 times 5V, that is 140V. And I guess we just have to solve this quadratic right now. Let's just do that. 28V squared, and then we bring everything onto one side, form this into a normal quadratic equation, like ax squared plus bx plus c in that form, you know? So 140 minus 536, that's going to be minus 396. The v, and then we're going to have minus 1360 equal to 0. Now what we're going to do is we're just going to put this straight into the calculator. We're not going to get into doing middle term factorization and stuff. Hell no. Minus 1360. Wait a sec. Minus 1360. Okay, we got it. So we have, okay, in the calculator, of course, we're just going to get two values. Like I got one v is equal to 17, and the other one being v is equal to minus 20 by 7. But just instead of writing these two answers or roots down, what I'm going to do is write these down in factors first. So we have v minus 17 multiplied by 7v plus 20 equal to 0. You see what I mean? Well, we take the 7 here first, so we get 7v, and then we have plus 20. Okay, that's how we get these factors, and then we can just write down v is equal to 17, and then v is equal to minus 20 by 7. But I know that v is just a magnitude here. V is literally just speed, and speed, you can't show it with a negative sign. This is clearly not applicable. Okay, this is clearly not applicable. This is clearly not applicable. Okay, now, this is going to be our value for v, and, yeah, sorry, I was just fumbling there with my pronunciation. What was that? Not applicable? Applicable? Okay, never mind. Alright, so we have find the deceleration of the motorbike. Deceleration, okay, so essentially the deceleration. We're decelerating when we're moving from B to C. Okay, so I think we just have to use one of the Suvat equations. Let's just erase this down, and then what do we have? Well, we know the distance traveled from B to C, that is 136. Okay, one thing you could do is literally just find out the gradient of this line. That is the simplest way to find out the acceleration or the deceleration. You could also use Suvat. However you do it, you're going to arrive at the same answer, okay? Just trust me. If you don't, why don't you do it? And you're just gonna get a, you know, a realization or something, a sense of peace maybe, and you'll just be fascinated, I hope. So I'm not gonna do this with Suvat. I'm just gonna strictly just take the gradient. And we did just find out the value of v, that is 17. So this is 17. What I'm gonna do is write down the coordinates here. T1 and 17. Okay, now one more thing is that we have to find out T1. That is not a big deal, right? Well, we just found out the value of v. We can just put that v into this equation for T1, and I think we're gonna get 17 plus 5. 17 plus 5 is 22. So 264 divided by 22 is gonna be 12. So T1 is actually just 12. And what about T2? Well, T2 is gonna be 28 minus 12. That's 16. Whoops, I'm not gonna erase that. The length of this is going to be 16. But this right here is going to be 28. And of course, in the exam, you won't erase this. I'm just doing this for my own sake, okay? Don't bother. Okay, so the coordinates of this point right here, of point B, is going to be 12 and 17. And then here for point C is going to be 28 and 0. So what is the gradient? Okay, they're asking for deceleration. So what you could do directly is just write this down. Okay, deceleration is just the magnitude, because when you just strictly find out the acceleration, or in this case the gradient, through gradient, then you're gonna end up with a negative value, which is right. That is what deceleration is, a negative acceleration. But they're asking specifically for the deceleration, right? They're asking for the deceleration. So we can't include that minus. So when we say we decelerate, we just say that we decelerate at 5 meters per second squared. We don't say we decelerate at minus 5 meters per second squared. No. When we have to say it in terms of acceleration, we say we accelerate at minus 5 meters per second squared. We automatically know that we're actually decelerating since it's negative. Yeah, that's the whole theory behind it. And deceleration is just going to be the magnitude. What is the magnitude? We just show it like this, okay? And this is the gradient, okay? The gradient is gonna be, we're gonna take b first. No, actually, yeah, it doesn't matter. b first is y2 minus y1. That's 17 minus 0 divided by 12 minus 28. Now I put this magnitude sign so that, okay, let me just show you what happens. 17 divided by 12 minus 28 actually just gives us minus 17 over 16. So you see how there's a minus here, and this magnitude sign is there to remove that minus sign. So this just ends up being 17 over 16 meters per second squared. And again, you can keep this answer, I think, just as it is, or just to be safe, I'm actually not too sure about that. You could maybe keep it in fractions. I have to visit Mark's schemes again. I kind of forgot. But yeah, you could just write it down like 1.06. It comes as 1.0625, but you can just put it 1.06 to 3 significant figures. This won't deduct any marks, okay? So don't be afraid of that. And we're done with that question. Thank God.